right, let's try here, okay? So let me see. Give you the NP junction here. And this is a P here, right? And this is N here. So this is W. Is it clear or you cannot see it? Can you see it?
I can see it.
All right, great. So here is, so the question tells you the stuff like that, okay? So here is, so what we can do is, we have QG there, right? QG, right? QG. We want to calculate the QG there, right? QG. The QG, what QG here? Is A, right? It's AQ, right? This A multiply Q multiply NA multiply ND and NA plus ND, right? W, makes sense to you?
I
right?
see. Okay.
Right. So so the situation is becomes here is let's say the W here. W is, we know W here, right? W is here is W here is how much W? 0.2. How much?
0.2 micrometers. And can you slide the paper up a little bit? You're off the screen.
Yeah, micrometer here, right?
Perfect.
Listen to you?
Yes.
Alrighty. So the A, that's A. Is A given or given? A we given here, right?
Yes,
10
it's
micron, right?
10 micrometers squared.
Right? Right? Q, how much Q?
1.6 times 10 to the negative 19.
Correct. What's the unit?
Coulomb.
Coulomb, yes. All right, great, perfect. So now it becomes NA and D stuff, right? Is it NA given or given?
NA is not given. ND is given.
Oh, look.
Which was 10 to
NA
the
not
16.
given, ND given. I think that probably very confused. NA not given, how come? How can calculate? There's no way I can calculate, right? Right?
Yeah, I guess that's partially what was tripping me up.
Yeah. Let's look here, right? Let's say NA far larger than ND, right? NA far larger than ND. So let's say, right, if NA far larger than ND, you can still see, right? Can you still see?
Yes.
If NA far larger than D, what we got? And we got here NA map ND divided by NA plus ND roughly equal to what?
Could you slide up the page a little bit?
Right. Great. See that?
Yes, perfect.
So this one, NA far larger than D, this equation becomes what?
Just NA.
On the denominator becomes what?
NA.
NA. The numerator still NA plus ND, right? Matter ND, right? Therefore, it's equally. This is not equal. This is not approximate. Not approximate. Equal. Not this is approximate. Equal. Equal to what? Equal to what?
Just ND.
Just ND. Perfect. Right. This is, let's tell this is a question. Homework 3. number 3. You can see here, right? Can you see this one here?
Yes.
Right. So students probably can take a benefit from knowing this. Okay. All right. So now this equation becomes QG AQ multiply what? Multiply
Just ND and then
D multiply W, right?
okay.
Make sense to you?
Yes, because I was looking at the D2L lecture notes for the total charge equation. I guess that was what was confusing me.
Right.
But yes, making the assumption of ND. I guess I kind of knew that from the previous part of the problem, but yeah, I was trying to follow along with the barrier voltage equation or with barrier voltage equation of total charge on D2L, and that was a little confusing. But this helps out a lot.
All right. Perfect. Awesome. Great. Yeah. So that's the idea, right? Make sense to you? And then you plug the equation there and calculate. Okay.
Perfect.
Right. Do you
I'll
need
have it done by the end of the day.
anyone need help on the Brilliant voltage as well, or no one need help? Brilliant voltage. Everyone, Brilliant voltage is okay.
Sure, we could figure it out.
And anyone need help on the Brilliant voltage side?
Sure, why not?
Mm-hmm. Alrighty, let me leave a help on Brilliant voltage as well. Okay, just make a complete. All right. On the Brilliant voltage side, and call the second part of question number 3 is ask VO, right? VO is again the Brilliant voltage, right? Right. So this one here is the Brilliant voltage equation is, as we know, W equal to this one equation here, right? W, this NP junction depletion region, the width, right? Again, W, remember depletion region or NP junction, right? Depletion region width, right? So here is the equation is related to emission Q multiply 1 divided by NA plus 1 divided by ND multiply VO, right? Right? We also know NA far larger than ND, right? Right? Right?
Yeah.
Right. So you use this with the value of the electron permittivity and divide that by Q, right?
Right.
It's kind of the same
right.
assumption
Yes,
that we just made.
very, very smart. So this because and there W can be approximate. There's 2 electron permittivity divided by Q. This one NA just ignore it because too far, too big than ND, right? Just become 1 divided by ND, right? Multiply VO, right? Listen to you. Right? And W therefore is 2 emission Q and D VO, right? Listen to you. Therefore, VO, this Brillouin voltage, is equal to omega square, right? Square on both sides. Left side square, right side square, right? Omega square divided by 2 emission Q and D, right? All right, omega here is, what's omega here? This no omega W, sorry, W. W is 0.2 micrometer, right? Image, how much image here? Electron permittivity, right?
Yeah, it
How
can
much
either be the
electron
11.7 times 8.85 times 10 to the negative 14th, or I think there was a simplified version.
Sorry?
It was the 11.7 times, or multiply that by 8.85 times 10 to the negative 14th. You could do that way, or I think you had another way on the D2L slides. That was just the way that I did it.
Right. Yes, yeah. It is there, right? It is there. Okay, it is there. Yeah. So yeah. So this image here, yeah, image here, you can simplify just like 1.04 multiply 10 over negative 16. Is that answer you got here, Zach? Is that answer you got? You're not really. Immature.
What did you for which answer? Sorry.
Immature.
Yeah, you're talking about the
Electron
the
permittivity.
1.04 times 10 to the negative 12. Yes.
Right. Is that what you got? You got different things.
Yeah, and my final answer for VO was 0.309 volts. I think that was correct. Maybe I'm wrong.
Yeah, it's close. Yeah, you're pretty close. Yes. Right. Yes. Thank you. Appreciate it. Was Q again?
The 1.16 times 10 to the negative
1.6, right?
Or sorry, 1.6. Sorry.
To negative 19, right? Right.
Correct. Coulombs.
Right. Great. And ND, what's ND?
10 to the 16th per centimeter cubed.
Right. Great. Alrighty. So that's pretty much. So alrighty. Everyone have other questions?
If I do, I'll ask you later.
Yeah, I said if I do, I'll email you.
Sure, certainly. That's absolutely.
All right.
Yeah, thank you for clearing that up. I'll have the homework done later today, probably.
Sure, no problem. Alrighty. Appreciate that.
All right. Thank you again.
Right.
Thanks.
Thank you. So Matthew is Steve able to follow through?
Yeah. Yeah, we'll follow.
Perfect. Awesome. Yeah, sorry, this a little bit blurry because this pen here doesn't work very well. You know. Can you see it or not? Matthew, can you see it? You cannot see, Steve.
Yeah, I can see it.
You can see. All right, great, awesome, beautiful. That's great. Yes. Alrighty. So yeah. So that's